Yes, hello everyone. Today we will start with another problem on Bode plot. Okay, here the main difference is in the denominator you are having the quadratic factor. Okay, either that may be in the denominator or in the numerator. Then how to solve the problem? We will see regarding that one. Okay, here the procedure remains again same. Okay, first thing is here they have given that g of h of s is equal to 200 s plus 2 divided by s into s square plus 10s plus 100. Okay, we have to convert this in the form of ts plus 1, ts plus 1, but this is in the form of s plus 2 is there. I want in the place of 2 1, and I want in the place of 100 1. Okay, to convert that one, what I will do, I will take the 2 common. Okay, this will become 0.5 into s plus 1. If you take the 100 common here, that will become s into 0.01 into s square plus 0.1 into s plus 1. Okay, then what we have to do, we have to substitute s is equal to j omega. We have to substitute s is equal to j omega. After substituting the s is equal to j omega, what happens here? You can see here that is 4. If you cancel this one, 100 and 2 into 2, then 2 into 2 is 4. 0.5 to j omega plus 1. Okay, divided by j omega 0.01 j square omega square for here 0.1 j omega plus 1. Okay, after writing this one, we have to again go for the tabular column. Okay, tabular column remains same again here. That is factor, corner frequency, slope contributed by individual factor, combined magnitude plot. Okay, combined magnitude plot. Here again the first one is constant. Constant is the 4. Okay, and second one is the 1 by s term. This is the 1 by s term. To write the next factor, we have to take the coefficient of this s. Coefficient of s. What is the coefficient of s here? That is 0.5. 1 divided by 0.5 is 1 divided by 0.5 is 2. What is the coefficient of here s square? That is 0.01. Okay. If we have the s square factor in the numerator or denominator, to find out the common frequency, we have to take the square root of 1 divided by coefficient of s square. That is 0.01. This will comes around 10 radian per second. 10 radian per second, and this is 2 radian per second. See, this is the important here. To find out the common frequency, that is the one important point here. Okay, what we have to do? Square root of coefficient of s square, reciprocal of coefficient of s square. You have to take. Then whatever the value you get, that will become your corner frequency. Hence, this factor has the least corner frequency, and this has the highest corner frequency. Hence, here I have written the factor as 0.5 into s plus 1. This is the third factor, and the fourth factor as that is 1 divided by 0.01 s square plus 0.1 into s plus 1. This is the fourth factor. Next, this is regarding the first column. Second column, there is no corner frequency for constant, and there is no corner frequency for 1 by s term. To find out the corner frequency, again same, omega 1 is equal to, that is 1 divided by 0.5, that you will get around as 2 radian per second, and omega 2 is equal to, because here we are having the quadratic factor, hence we have to go for the square root of 1 divided by reciprocal of, that is the reciprocal of coefficient of s square, reciprocal of coefficient of s square under root. Okay, then what happens? 1 divided by 0.01. Okay, this comes around 10 radian per second. Okay, for this one, only for this term 100, we get the 100, and the square root of 100 is 10. Square root of 100 is 10. Hence the corner frequency is 10 radian per second. Okay. Next, the slope contributed by individual factor. Slope contributed by individual factor. Okay, it is 20 log 4, that is equal to 12.04, but we have taken for our convenience 12 dB. And here this is in the denominator, hence I have taken the minus 20 dB per decade, and this is in the numerator plus 20 dB per decade, and this is in the denominator and square, hence I have taken the minus 40 dB per decade. This is regarding the third column. Next, to write the fourth column, combined magnitude plot. Okay, here as usual there is no changes at all. Okay, draw a straight line at 12 dB. Here whatever the value is there, you have write that value here. Draw a straight line at 12 dB. Okay, what is the value here? Minus 20 dB per decade. You have write that value minus 20 dB per decade starts from 0.1 to 2 radian per second. Okay, this is the standard value. We have to always take this value as 0.1. 0.1 to 2 radian per second. When we have to change this value instead of 0.1, if this next first corner frequency is less than this one, okay, say 0.09 or 0.02, during that time we have to change the starting value as 0.01, okay, like that we have to see here 0.1 to 2 radian per second, okay. For this minus 20 we have to add this plus 20, minus 20 plus 20 is 0, hence I will write here 0 dB per decade starts from 2 radian per second to 10 radian per second. Here 2 is there, okay, 2 radian per to 10 radian per second. Next last one, for this 0 we have to add minus 40, minus 40 dB per decade starts from 10 radian per second onwards, 10 radian per second onwards. This is regarding the tabular column. Next, to write the equations, first equation is simple, okay, there is no complicated at all. That is 20 log 4 minus 20 log omega by considering this 4 and this s factor, these two factors. That is 20 log 4 minus 20 log omega is equal to, then here we will take the two values, that is 0.1, 2. For 0.1, 32 dB, for 2, 6 dB. Okay. Next, we have to consider the 1, 2, 3 factors. Okay. Then I will write here 20 log 4 minus 20 log omega plus. Why plus? Is because this term is in the numerator. Hence, I will write the plus. Okay. 20 log 0.5 to omega. 0.5 to omega. What is the range here? That is 2 to 10. 2 to 10. That is equal to 6 dB. And here also you are getting the value as 6 dB. Okay. Next, this is important. 20 log 4 minus 20 log omega plus 20 log 0.5 to omega minus here, because here we are having the quadratic factor. Hence, I have written the 40 log here 0.1, because see in this term, if you multiply 2 into 0.5, then that will become 1. Is it right? If you take this value, here also we have to consider that value like this. If you multiply this 0.1 into some value, that value, this value must become 1. Okay. Hence, if you multiply this one with the 10, then what happens? You will get this value as 1. Because if 40 log 1 is 0, okay, then again you are getting the 6 dB as the same value. Hence, there is a concept here. Okay. If you take this value, if you want to write this value, okay, then the starting value is 2. Okay. If you, with respect to 2, if you multiply what value, then that will become 1. Okay, 2 into 0.5, then this value will become 1. Okay, here we are having the 10. If you multiply with 10, then what value you will get? You will get the 1 as the answer. 0.1 into 10, then your value will be 1. Okay, for 10, you are getting the value as 6 dB. For 100, you are getting the value as minus 34 dB. Okay, and here the value is changing from positive to negative. Hence, we have to equate this equation to 0. Then we are getting the value as, that is 14.14, then where the value is 0 dB. What is this 14.14? That is gain crossover frequency. Gain crossover frequency. Here the thing is to write this value 40 log. Okay, this value must be 1 after multiplying the 10, because here the last value is 10. 10 into some value. Okay, that value must be 0.1. 0.1 into 10 is 1. Okay, here also same thing. That is 0.5. 2 into 0.5. That value will become 0.1. Okay, this value will become 1. Like that, you have to write this starting values. Okay. After this, we are having that phase angle equations. Phase angle equation. For phase angle equation, here we have to be very careful, because this is a quadratic factor. Here we are having the quadratic factor, hence we have to be very careful here. To write the phase angle equation, just you can see here, I have taken already the same thing. Whatever the things they are given, I have taken the same. But instead of writing s square plus 10s plus 100, I have taken the factor for this one. That is s square plus 10s plus 100. Then what happens? That we will get the factor as s plus 5 plus j into 8.66. S plus 5 minus j into 8.66. You are writing this value. Okay. See here, instead of writing that s square plus 10s plus 100, here I have written the two factors. That is this is important in this quadratic factor. This is the important in the quadratic factor. Next, what we have to do? We have to put s equal to j omega. Then we'll get the fact value like this. Next, we have to write the phase angle equation. Phase angle equation we have to write. Okay, phi of omega is equal to minus 90. Because why minus 90? Because j omega is in the denominator, minus tan inverse of c. If you consider these two factors, if you take the j as the common, then omega plus 8.66 and real part is 5. Okay, minus here also same thing. Omega minus 8.66 and real part is 5. Plus this is in the denominator. This factor is in the denominator. Tan inverse of omega by 2. Tan inverse of omega by 2. And one more thing is here. If you equate this equation to minus 180 degree, you will not get any value. If you equate this equation to minus 180 degree, then you will not get the any omega value, because see, if you consider the one factor, okay, for if you consider tan inverse, okay, tan inverse of one factor, for each factor has the value as 90, okay, minus 90, minus 90, minus 90, okay. If you add all the three values, then that will become minus 270. For that minus 270, if you add the plus 90, then that will become minus 180. See, for the higher value of omega, you will get the minus 180 degree. Hence, you are not getting the minus 180 in this problem. Hence, it is not necessary to equate this equation to minus 180 and find out the omega p. Here you will not get the omega p value. Okay, that is also important in this problem. After that, we have to go for like a tabular column. Okay, here we have got the omega g as, that is omega g is equal to 14.14 radian per second. Above this one, 10, 20, 30, 40, 50 like this. I have taken around 5 to 6 values. For 10, minus 101. For 14.14, minus 133.31. For 20, minus 152. 30, minus 163. 40, minus 167. For 50, minus 170. Like that, you are getting the values. Okay, and here we know that omega g is equal to 14.14 radian per second, and you will not get the gain margin, because gain margin value is positive. Okay, for this I will send one PDF for you to understand how to write the gain margin positive and how to write the gain margin negative. Okay, and the phase margin is, that is minus 133.31 plus 180, then 46.69 degree. Okay, hence both the values are positive. Hence the closed loop system is stable. Okay. Thank you. Next, in the next video, I will show you how to draw the graph.